maadadan maanta qaadanayna waa mathematics. Waxaan soo qaadanay laba subtopic oo ku saabsan cashirkan numbers, sets. Cashirka maanta aan qaadan doono waa Venn diagram. Cashirka hore waxaan soo qaadan universal sets, intersection, union, and complement of a set. Now we said universal set is a set which contains all the elements under discussion. Union, we said union is elements in both sets. Intersection, we talked of common elements between the two sets. Complement of a set, we said a complement means elements which are in the universal but not in the set given. In today's lesson, we'll be discussing Venn diagram, learning outcomes. The learners will be able to define Venn diagram, describe the procedure and labeling a Venn diagram to represent intersections and union of two sets, solve word problems using Venn diagram. That will be our last learning outcome. Now, a Venn diagram is a visual representation of a circle. We use circles to represent Venn diagrams. Now, example, read the Venn diagrams and answer the following questions. Now, in this Venn diagram, we have two circles. We have two circles. And we have some element inside, CD, E, J, and F. A, B, G, and H. I. This place is known as the intersection or the overlap. Overlap. This is set A and then set B. What comes and inside this rectangle is known as the universal set because it is the set under discussion. Now, question number 1 reads, A complement. A complement means all the elements which are outside A. So therefore, A complement will be equal to, outside A is A, B, G, H, and I. So these are A complements, elements in A complement. B complement means all the elements outside B. Outside B we have E, J, F, H, and I. So these are also A complements. A union B. A union B is, union means all the elements in both sets, that is A and B. So all the elements under these two circles are E, J, F, C, D, A, B, and G. So that is A union B. A intersection B is the elements in the overlap. The overlap we have C and D. Lastly, we have A union B and then complement. A union B complement is outside these two circles. We have H and I. So that is A union B. That's our first question. Example number 2. Example number 2, we have two intersecting circles. We have these two circles. We also have another circle inside and another one here. So this is W, Y, X, Z. Elements, we have 8, 6, 7, 2, 9, 3, 1, 10, 4, and 5. Now question number 1 reads, copy and complete the following. W intersection X. W intersection X. That is the overlap between these two sets. That is W and X. So the overlap will be, we have W intersection X. We have 2, 9, 6, 7. The order of writing the element is not important. So B, Y union Z. Y union Z. Y union Z. Y union Z will be Y union Z. So this is disjoint set because they don't have elements in common. So this one is an empty set. So this is an empty set. They don't have elements in common. They don't have elements in common. Then next, W complement. W complement means outside W. Outside W we have only 3 and 8. We have only 3 and 8. Now the relationship between Y and W, the relationship between Y and W is Y is a subset. Y is a subset of W. Y is a subset of W. Word problems involving sets. Example. Let A and B be two finite sets such that number of elements in A, we have 20. Number of elements in B, we have 28. And then N union A union B is 36. Then you are asked to find N number of elements, that is A intersection B. There are two different ways of answering this question. One way is you write the general formula. You say N A union B is equal to number of elements in A plus number of elements in B minus number of elements A intersection B. A intersection B. So the union you are given, the union is 36. 36 is equal to the number of elements in A, we have 20, plus number of elements in B, 28, minus number of elements in A intersection B. So A intersection B. So you add these two together, you get 48. 48 minus N into bracket A intersection B. There you have 36. So you transfer this onto this side, you get 36 minus 48 will be equal to minus N A intersection B. Then these two you subtract, you get minus 12. Minus 12 is N into bracket A intersection B. Therefore you cancel the two negatives. Therefore N A intersection B will be equal to 12. That is one way of answering that question. Another way is you just draw two circles representing the A intersection B. So we have B there, This is A, this is method 2, and this is method 1. So we have inside we don't know, just call it X. This side you are given 20, and then this side you are also given 28. You know the total is 36, so therefore you just write, you say 36 is equal to 20 minus X, because there are some elements in B here, so therefore you just subtract minus X there, plus X, so you just subtract plus X, plus 28 minus X. So this will be equal to 36, that is 48, minus X plus X is 0, therefore there you also have minus X, you transfer this one to the left, you get minus 12 is equal to minus X, therefore X is equal to 12. That is another way of answering that question. Example number 2. In a group of 100 persons, 72 people can speak English, 43 can speak French. The question is, how many can speak English only? So we know that the total is A union B is 100. Let's say set A be people speaking English, speak English. B, let's say speak French. So the intersection, I'm sorry, the union is 100. So you just say A union B is equal to number of A plus number of B minus the intersection A intersection B. So this is total 100. 100 minus 72 plus 43 minus X, or just call it N intersection A intersection B. So there you get 100 equal to 115 minus N intersection A intersection B. Therefore you get A intersection B will be equal to 100 minus 115 minus 100, you get 15. So that is example number 2. In a group of 60 people, 27 like cold drinks, 42 like hot drinks, and each person likes at least one of the two drinks. How many like both coffee and tea? Again, the intersection. First of all, you write N, that is A union B. A union B is the total number of the people, they are 60. Those who drink cold drinks, they are 27. So let's just say set A is 27. Set B, there you have 42. So therefore, we are asked to find how many likes both coffee and tea. Again, the intersection. You say number A union B is equal to NA plus NB minus N into bracket A intersection B. So therefore you write 60. This one we are given 27 plus 42 minus X representing the intersection. So 60, that is 69 minus X. You transfer this one to the left, you get minus 9 is equal to minus X. Therefore X is equal to 9. So 9, this is the intersection, meaning they like both hot and cold drinks. The Venn diagram, the last question, the Venn diagram below shows the number of elements in 3 sets, set P, Q, and R. Set P, Q, and R. That is the 3 sets, set P, Q, and R. Here we have 13 plus X, 15 minus X, 10 plus X, X, this is 10 minus X, 12 minus X, then 20 plus X. Now the question is, if the union of these 3 sets is equal to 93, find or calculate X. The union of all these 3 is 93. So therefore we add all these elements together. So 10 plus X, 15 minus X, 13 plus X, plus X, plus 10 minus X, plus 12 minus X, plus 20 plus X. All of these add up to 93. That is the union of all the 3 sets. So we add all these numbers together. 10 plus 15 is 25, plus 13 is 28. No, 38. 38 plus 10 is 48. 48 plus 12 is 60. 60 plus 20 is 80. I said 10 plus 15, 25. 25 plus 13 is 38. 38 plus 10 is 48. 48 plus 12, there you get 60. 60 plus 20, you get 80. So that is 80. Plus x minus x is 0. X plus x is 2x. 2x minus x is x. Minus x. X minus x is 0. Therefore, you have only one x there remaining. Is equal to 93. So therefore, x will be equal to 93 minus 80. 93 minus 80. So therefore, x remains here 13. 10 plus 15 is 25, 38, 48, 60, and then 80. That's correct. So x is equal to 93. The value of x is equal to 93. The value of x, is equal to 13. The first question is calculate x. X is now equal to 13. B, number of P, that is 10 plus x. What comes under this circle is, this is question number 1. Question B reads 10 plus x plus 15 minus x plus 10 minus x. So we know that the value of x is 13. So therefore just add x minus x is 0. Therefore again x minus x is another 0. So therefore the total will be 10 plus 15 plus 10. There you get 35. 35. So intersection P intersection Q. P intersection Q. P intersection Q is this overlap. That is P intersection Q. P intersection Q. That is question, the last part. 15 minus x plus x minus x plus x is 0. So therefore the intersection is equal to 15. That is now the last question we were supposed to discuss today. So I request the students to do the exercise on the link below. بسم الله الرحمن الرحيم. بسم الله الرحمن الرحيم. بسم الله الرحمن الرحيم. waxaa noo soo dhamaaday chapterka koowaad sets form 3. waxaan bilaabaynaa chapterka labaad algebra qaybtiisa koowaad waa graphs in practical situations. Under this algebra there are three main topics. Introductions, we have motion graphs, straight line, and matrices. Our first topic will be graphs in practical situations. Distance, time graph. Distance, time graph. Now the learning outcomes, by the end of the lesson, learners should be able to interpret and use graphs in practical situations, interpret and use conversion graphs, distance time graphs, and interpret in real life situations. Distance time graph. Distance is always written in the y-axis. So this is distance. And you normally write meters, that is the SI unit. Time in the x-axis. And then you write seconds. Now distance time graph tells us how someone or something has traveled and how long it took them or it do so. Now these are examples of certain graphs. The first one is a graph that starts at that particular point and then moves straight. If you try to find the gradient, of this line, you get constant gradient. Let's take some points on this line. Let's take some points on the line, and when you find the gradient of this line, that is gradient is equal to a change in y divided by change in x. Now if you divide, let's say A, B, C, and then D, and then you have some points here. This is the x-axis. Now for me to find the gradient of AB, I have to divide a change in y divided by change in x. So that is my change in y. Change in y, that is, call this one, let's say this particular point is E, and then F. You say AE divided by, call this one PQRS. PQR and S. So AE divided by AB. These two lines is EF, the second one, EF divided by PQ or QP. The last one is, let's call that to point M or K. So we say KF divided by QR or RQ. So you will get constant gradient. The gradients will be constant. The gradient will be constant. So that is the first one. The second one is, the first one, the gradient is positive because it is moving that way. The second one, the gradient is negative, decreasing speed, that is decreasing speed. So change in y divided by change in x. Change in y divided by change in x. This one is decreasing speed. And this one is increasing speed. The next one is constant gradient. This one, the gradient is negative. The third one, the gradient is 0. This is a state of rest, that is. State of rest. Or stationary, that is. So if you find the gradient of this particular line, let's take this as, call this one A, and then say 1, 2, and then 3. For me to find the gradient of this line, for this particular point A, let's say we have 1, 3, B, we have 2, 3. So the gradient will be equal to change in y divided by change in x. So 3 minus 3 divided by 2 minus 1, and then you get 0 divided by 1. The answer becomes now 0. So the gradient is 0. That is the third graph. The fourth graph is, the first one is increasing, and then it first of all starts with increasing, and then it slows down. So the gradient here is positive, and then when it comes to that, this one changes now to negative because it is coming down. The next one is increasing speed. The increasing speed. If you try to find the speed, you get, first of all, you draw tangent lines. You draw tangent lines to find the gradient. So change in y divided by change in x. This one you always get the gradient is positive and it is increasing. The last one, increasing. This one is decreasing speed. This one is also increasing speed. This one is increasing speed. Increasing speed, and this one is decreasing speed. Now, key points to remember: the gradient of the line is always equal to the speed. The gradient of the line is always equal to the speed. So that one is the speed. The gradient is the speed. The flat region, that one is state of rest. This is rest. This is constant speed. That is d against t. This is constant. And then this is coming back or return, coming back or return. So therefore this one is decreasing speed. Negative gradient, the gradient of this line is negative, the gradient of this line is positive, and this one, the gradient of this horizontal line is 0. The speed tells us the rate at which an object moves. Example. Examine this graph carefully. That is the graph. Question number 1 reads, what is the track displacement from its starting point after 10 seconds? After 10 seconds, it will be 300 meters. After 10 seconds, it will be 300 meters. 15 seconds, just go where 15 is. 15 is between 10 and 20, and then you draw a line. That line will be again 15 seconds will be again 300 meters. 15 seconds will be 300 meters. 30 seconds. is 200. 30 seconds is 200 meters. 30 seconds is 200 meters. 50 seconds. 50 seconds is 800 meters. 50 seconds is 800 meters. Example number 2. Example number 2. The speed time graph shows a 50-second car journey. Calculate the total distance traveled over the 50 seconds. Now, total distance is equal to area under the curve. Area under the curve. Total distance is equal to area under the curve. Now that is the graph. This graph is something like this. Let me just draw it on the board. We have up to there we have 15, I'm sorry. We have that horizontal line, which is there we have 10, there we have 20, and then that line, up to that line is 25, and then this is return or coming down. So there we have 30, and then lastly 50. This is 40. Now let's try to find the area of the first one. We subdivide. So A will be equal to, since this one is a triangle, you just write a half base times height. So a half times the base is 10 times the height, which is 15. Therefore you get by 2, 1 by 2, 5, you get 75 meters squared. So the next one, A2 or B is a rectangle, so it will be, the difference is 10 here, and then this height is 15, so this is a rectangle, is LB, so this will be 10 multiplied by 15, you get 150 meters squared. C, that one, this one is shape of a trapezium. This is the shape of trapezium. So this is my A and this is B, and this becomes the height. If I try to remove this one, it will be something like this. It will be something like that. So therefore this side is 15, this side is 25, and then my height will be equal to 10. So area will be equal to a half H into bracket A plus B. Therefore this will be a half multiplied by height, which is 10, into bracket 15 plus 20. 15 plus 25, sorry. So this will be 5 by 2, 1 by 2 is 5. You get 5 multiplied by the addition of these two, you get 40. So 40 multiplied by 5, you get 200 meters squared. That is the area of that. Then lastly D is also, this one is a triangle. So we have the base will be 20 and then the height will be 25. So a half multiplied by the base, which is 20, the base is 20, that is 50 minus 30 multiplied by the height, which is 25. You get by 2, 1 by 2 is 10, 10 multiplied by 25, you get 250 meters squared. So we are told to find the total distance. We said the total distance is equal to area under the curve, so we add all this. So total distance will be equal to the summation of all this, so that will be 75 plus 150 plus 200 and then plus 250. So this is 225 plus 450, you get 675 meters. 675 meters. So that is the distance, the total distance covered. That is the total distance covered. B, find which section of the graph has the greatest speed. The greatest speed, we have A and the last part. So the greatest speed is A. We try to find the greatest speed. We say the first one is a half base multiplied by the height, which is 10 multiplied by 15. There we got 75. The next one, that is by 2, 1 by 2 is 5. The next one also, C, the greatest speed. B, the speed is 0. C, the speed will be a half multiplied by the base, which is 10, multiplied by the height. The height is the difference between 25 and 15. You get 10. So therefore, you get by 2, 1 by 2 is 5. You get 50 meters, 50 meters squared. I'm sorry, that's another meter squared. And then, so the greatest speed will be A. A has the greatest speed. A has the greatest speed. A has the greatest speed. Question number 3. Billy drove 60 kilometers from his home to Liverpool. He stopped and visited his friend Ali on the way. So that is the graph for Billy. And then you are asked, question number 1 reads, work out Billy's speed for the first part of his journey. The first part of his journey is the distance he traveled from, the time he traveled was 13 up to 14, that is 1 hour. And then the height, that is the distance, which is 30 kilometers. So therefore the speed for this one, that will be equal to distance divided by time taken. Distance divided by time taken. So the speed is distance divided by time taken. The distance is 30, and then the time taken is 1 hour. So we have kilometers there, and then this we have 1 hour. So this one becomes 30 kilometers per hour. 30 kilometers per hour. Question 2, how long did Billy spend visiting Ali? That is the rest time. He was there for, that is between 14 to 15 is 1 hour, and then half of 15 to 16, that is 30 minutes. He was there for 1 hour and 30 minutes. That is question number B, 1 hour and 30 minutes. C, work out Billy's speed for the last part of his journey. The last part of his journey, that is C, speed is equal to, again, distance divided by time taken. The distance is 60 minus 30, you get 30. And then the time taken will be, that is 30 minutes. Plus 1 hour, you get 1 hour and 30 minutes. So 1 hour and 30 minutes is the same as 1.5 hours. 1.5 hours, that will be 30 divided by 3 divided by 2. 3 divided by 2 means you change this one to improper fraction. So this multiplied, you just multiply, you say 2 times 30, or 30 times 2 divided by 3. By 3, 1 by 3 is 10. 10 times 2, you get 20 meters per second. 20 kilometers, I'm sorry, per hour. I'm sorry, this is 20 kilometers per hour. I'll stop it there. I therefore request students to do the exercise.